Okay, let's dive into a fascinating open source tool called stmax-gui. It's this perfect little story about a very specific problem, a super clever solution, and honestly, a surprising peek into the future of how these kinds of tools are probably going to be built from now on.
So right off the bat, here's the little detail that really caught my eye. Tucked away at the bottom of the project's page, it just says, this project was built with GPT-4. Now, we're going to circle back to that for sure, but it just sets the stage for a really modern tale of problem solving. So before we get into how it was made, let's talk about why it was made. What specific headache does a tool like this even exist to cure? Well, it all starts with a powerful, but kind of tricky piece of hardware. To really appreciate just how neat the solution is, we have to get our heads around the puzzle first. And that puzzle involves a pretty specialized piece of equipment for radio enthusiasts and, professionals in that space. Okay, so this is the STMX transmitter. The simple way to think about it is that it's the heart of an FM radio broadcast setup. It's the board that actually generates the signal. It's super powerful, but getting it configured just right, yeah, that's not exactly plug and play. And here is the core of the problem. See, to set this thing up, you traditionally need this whole separate LCD controller board. So you're physically plugging things in, you're trying to navigate menus on a tiny little screen. It's slow, it's awkward. There's just no simple, standard way to plug it into your computer and configure everything in a nice, clean interface.
And that, right there, brings us to the hero of our story. A piece of software that takes that entire clunky process and makes it elegant and, well, simple.
The central idea is it's brilliantly simple. Why wrestle with an extra piece of hardware when software can just do the job better? Let's just talk to the transmitter board directly from a computer. Easy, right? The project page really summarizes the whole goal perfectly with this quote. The software completely takes the place of that separate LCD controller, which just simplifies the entire setup. You can basically think of stmax-gui as a universal remote. It takes all the complex functions of that transmitter and puts them into a simple, clickable interface right on your desktop. It gives you full control without any of the physical hassle. So, how does it actually work? What does using this universal remote actually look like for the person using it? Let's take a look. The workflow is just so logical, it's beautiful. You connect the board with a USB cable, and boom, the app finds it. You click Read, and it pulls all the current settings right from the device onto your screen. You tweak them in the app, and then you click Save to write those new settings back to the transmitter's memory. It's really that straightforward. Now, this is where the solution gets even smarter. It's not just some dumb terminal for sending commands back and forth. It actually understands the hardware it's talking to. And because of that, it provides this really important layer of safety. And this is that safety net in action. The app has these validation rules built right in. So it knows the power setting can't go above 100, and it knows the frequency has to stay within the legal FM band. This literally prevents you from accidentally typing in a value that could cause problems or maybe even damage the hardware. So we have this really elegant solution to a real-world problem, but the story gets even better when you look at how it's been shared with the world. See, this isn't some expensive proprietary software you have to buy. No, it's completely open source under the MIT license. Anyone can download and use it for free on both Linux and Windows. And here's a key feature. It's a single self-contained application. You don't need to install Python or any other frameworks to get it running. You just run it. And for those of you who are interested in the tech stack, the language choice here is pretty revealing. The app is written almost entirely in Rust, which is a big deal. Rust is known for building software that's both incredibly fast and super safe, which makes it a perfect fit for something that's directly controlling hardware. So let's just pull back for a second and look at the big picture here. What does a small project like this really represent? I mean, you can see the entire transformation side by side right here. We go from a cumbersome physical process to a simple, direct software interface that has safety rules built right in. It's a classic story of digital control replacing mechanical complexity, and it just completely empowers the user. Ultimately, this project is just a perfect little microcosm of modern open source development. One person sees a specific problem their community is facing, they build a focused, elegant solution, and then they just give it away for everyone to use and improve upon. It's awesome. And that brings us right back to where we started. This entire polished, useful application was built with an AI coding assistant. See, this isn't a story about AI replacing developers. It's about AI empowering them. It's a force multiplier. So the question to leave you with is this. If one person with an AI partner can solve this niche problem so elegantly, what happens when millions of creators and tinkerers and builders all have that same power? What problems are they going to solve next?